action. Okay, so happy Monday, as happy as they get, I guess, with things crashing all around me. So what I want to do today, and we'll see if my computer will let me, is just finish talking about some of those other visualizations that we could do, just to have a kind of a library of sorts where we can say, oh, well, I think I could maybe try, a line graph, or maybe I could try looking at a scatter plot, or maybe I could try looking at a bar graph or something like that, right? So we need that terminology, and we need to just be able to know what those should look like, right? And then this is a good time to start talking about data viz, so we call it in the biz, or data visualization in R, using ggplot, which you may or may not have used already. But we'll start from kind of the bottom. Now we're here. So, okay, we started, but it was all the way back on Friday, and I have to do a refresher. We finished and we kind of talked about cross tabulation. So we were talking about how should we set up our tables for them to look good. And so what we decided on was kind of the fewer lines, the better. Uh-oh, something's happening here. That's okay, I'll just ignore it for now, but okay. Fewer lines, the better, unless we're separating things, like we could separate the headers, or if we've done any sort of calculations in this time, in this case, we've looked at the totals, right? Then we usually have lines to separate those out. But otherwise, we're going to stick with kind of as few lines as possible, right? And focusing on only the data. Now, there was a ton of different things that we could say about this cross tabulation, right? We focused on this 42, but if we look at this 6, for example, right, there were 6 restaurants that had a rating of very good and a pricing between $40 and $49, right? And then we could talk about, okay, 6 out of 150 had a rating of 40 to, or had a price of $40 to $49 in the very good category, right? Because it's out of 150. Now we're focusing on that very good category, right? And so there are lots of things that we can say here, right? And the key is that we're talking about 2 variables at once. Whereas if we talk about just how many had a meal price between 10 and 19, well, that would be 78 out of 300, right? Then you would just focus on those margins, those totals. Okay, so going back to our summary notes here, right? So we talked about the cross tabs, and then I vaguely remember, but if I didn't write it down, I don't remember it either, talking about some charts. Some scatter plots, some line charts, blah, blah, blah. So that's where we'll start. So, I guess no review, because pretty basic stuff. But one thing I want you to note is that a chart is a plot, which is a graph. So I use all those interchangeably, right? And so we need to be kind of flexible when we read these, right? But as soon as we're talking about charts or graphs, we're visualizing data, right? And so we've already seen in the case of tables versus bar graphs, right? There are some instances where we're going to want to know the exact values, right? And then there are some instances, so then we should use a table. And then there are some instances where we just want to know the relative differences between two or more groups, for example. Let me just, it's complaining here. Let me just close that. I don't know. So if I'm visualizing two quantitative variables, the most common thing that I'm going to do is make a scatter plot, right? Oh yeah, and then I mentioned the scatter plot, and then I said I would dig that code up. You could probably just Google scatter plot, but I'll put it on my to-do list. Scatter plot code, because I said it, making big campaign promises here, and then I don't deliver. Scatter plot code. All right. It's important. No, it's not. It's just for fun. So if I have two quantitative variables, then we would look at a scatter plot typically. And so that's where we will eventually start our ggplot adventures. But for now, hey, just going to bring this in here. Okay. So if we have something like this, notice that we have, wait, the data here. Hey. The number of commercials for each week and the sales volume for each week. I didn't include very much of the description because it doesn't actually matter, because we're just looking at two quantitative variables, right? And so here, these are both quantitative variables. Right? The week number is just an observation number, so it doesn't really matter. There are instances where we might be interested in only week 3 data, for example. Then we would tease that out of there. But then presumably we would have more than just one observation at week 3, right? So what we get here is this kind of beautiful scatter plot, right? I think I have 2 dots for each number of commercials, which means that there were 2 weeks where there was only 1 commercial, 2 weeks where there were 2, 2 weeks where there were 3, 2 weeks where there were 4, 2 weeks where there were 5, 0 weeks where there were 6, right? And we've got this, it looks like a linear relationship, right? So we can talk about the relationship between these 2 variables, and this looks like a linear relationship. In fact, it looks a little bit positive, right? Looks like it's on an incline here. And so we could say a positive linear relationship if we wanted to. Right? We talked about the correlation, right? We've talked about the correlation before. So the correlation is the numerical measure of the strength and the direction of this relationship. Now, in terms of the strength, right, it would be quite strong because all these points are very close to each other, right? And so, and they're close to the line. And it would be positive, right? Because we see a positive relationship. Yeah. So the correlation for the data above, right? Just to tie it back into some of the old stuff that we were talking about in chapter 2, the correlation for the data above is expected to be positive and quite strong. Right. So probably larger than 0.7, 0.75, right? I'll say likely larger than 0.7 or 0.75, right? Just as a guess. Okay. So it's good to have, so we visualize these things just so we can get an idea of the numbers that we're expecting, right? And so we talked about the correlation, the actual value of the correlation before, right? But now we can visualize it and say, hey, if I see something like this, what am I expecting to see? Well, I'm expecting, when I calculate the correlation, I'm expecting it to be positive, and I'm expecting it to be quite strong, right? Because the points are close to the line, right? And so that's what I wanted to kind of bring home here, is there's a connection, and that's why we visualize things, is so that we can get an idea of what to expect. We often visualize data to get an idea of what values to expect, right? We saw that with the histogram too, right? Where we said, okay, I'm going to look at the shape, I'm going to look at the center, I'm going to look at the spread, and that gives me an idea of what's going on, right? And it gives me an idea of what to expect when I calculate the mean and when I calculate the standard deviation, although the standard deviation is kind of hard to put your finger on, but the mean for sure, right? And so that's a basic scatter plot. Then we have some line charts. Line charts we use specifically, they're specifically useful for time series. So if you have data over time, then we can use a line chart. Okay. So it is a scatter plot, okay, but the lines connect the points, and we use these lines to be able to follow trends, right? And so the lines make it easier. Right. The lines here make it easier to follow trends across time. Notice that the lines, let me make sure here, that the lines make it easier to follow or even detect, follow/detect trends over time. So when we have time variable, in this case, right, it can be months, it can be in minutes, it can be in years, it can be in quarters, it can be, so any measurement of time, minutes, hours, whatever. Right, so when we have time on the x-axis, is called a time series. Now we're going to get into some time series analysis, but honestly, time series analysis is its own game. Okay, so there are full textbooks that talk about time series analysis. So we're going to touch on some of the key things that we should know and be aware of. But just be aware that we're just going in, peeking in, and then shoving the lid down again, and then we're going to leave it alone, right? So if you find yourself in a field that requires a lot of time series analysis, then you'll probably have to study it quite a bit more, right? And so the reason for that is because here, if you have observations in January and February and March, right? There's that dependency between the months, right? You could argue that June observations might be independent of January observations, but not truly, right? Because this, whatever the north variable, whatever that is, doesn't matter. The north variable started high, right? And so we're talking about sales. So high sales, that's probably a good thing, right? And so the north variable started high in January, and then it's just consistently staying high even in June, right? And so where it started is going to matter, right? But then the previous month is also going to matter. So you lose that dependence, or sorry, you lose that independence rather. Critical word mix up, right? So you lose that independence that we have, or that we're assuming here when we're just looking at a scatter plot. We're just assuming that week 1, 2, 3, 4, although they seem to be time series, right? They are, but because we're not looking at it time on the x-axis, which we could, but we're not, right? So because we're not looking at time on the x-axis, then we can kind of ignore that aspect for a little bit. We should consider it later in our analyses, but here, because we don't have time on the x-axis, we can assume that there's some independence between these observations, right? And so any trend that we pick up on would be because of the relationship between the number of commercials and the sales, right? Not because of a time component necessarily. All things to consider. Okay, so special case is when you have a time series, and that's when it would be appropriate for us to draw lines here, right? Because that's when we want to map the trends, okay, over time. Whereas here, if I scroll back up, and again, I'm just kind of trying to please my computer so it doesn't do anything weird. Go nice and slow, even though that's my iPad, but it acts up too. I don't know. Unreliable. Or maybe I'm unreliable. Too fast. Right. So here, although I have dots, and something like Excel would let me connect the dots with lines, we don't want them there, right? They're not going to do anything, and they would just make a mess because we're not actually looking at the trends between the number of commercials, right? Because there's no time component, right? So when there's a time component, you can add those lines, otherwise they're not really relevant. So that's the tricky part, especially about something like Excel. Excel will just let you do whatever you want, right? If it's a quantitative variable, it'll just let you calculate the mean, the standard deviation, and just kind of have your way with it. But that doesn't mean it's always appropriate, right? There's no built-in function that says, oh, what you're doing is not appropriate, right? And so you have to be a little bit careful. So, we should only, I want to say typically, there are some rare cases where you could connect them with lines, but as a rule, we should only use line charts for time series, I'll say. Okay. I wonder if they have an example. I'm drawing a blank on a different scenario where we might be interested in a line chart, but line charts are very useful for time series data collected over a period of time. Hey, they're not even giving an example where line charts would be useful besides time series. So, okay, so I'm going to go ahead and draw the line then, and say that we should only use line charts for time series. Of course, there are instances where blah, 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 blah. But as a rule, that's a pretty good rule. Okay, so I feel like we already talked about bar charts, but maybe not. Oh yeah, we started with tables. Whoa. Okay. Then I'm off my rocker, but let's talk about bar charts now. Fine. That's fine. Wait for it to let me copy it, I guess. But I also want this example here. Okay. So bar charts and column charts, I'll choose Apple every day. Every day. Hashtag basic. I can't have anything but. Are you kidding me? So anyways, so for categorical data, the most common visualization technique that we use is a bar chart. And so a bar chart is just a bar of the frequencies, right? And so bar charts use horizontal bars to display the magnitude of the quantitative variable. Now, the magnitude being the frequency or the count, right, in each category. Remember from the tables, there's not a ton going on with categorical data. There's really just hey, there's a typo here. Quantitative. Categorical. Right? Bar charts use horizontal bars to display the magnitude of the categorical variable. Anyways, yeah, I feel like that should be categorical. Kind of a big typo. Magnitude, or I would probably call it the frequency. Anyways, I guess this one is looking at a quantitative variable down here. Yeah, don't tell Joe. I know. Am I missing something? I just kind of flipped through it and said, oh, yeah, yep, bar charts, whatever. But typically, yeah, I'm standing by what I'm saying here. But anyway, so what we have is we have some categorical variable, in this case, the name of the manager. Okay, so here, right, this is a categorical variable. Categorical variable, right, which is the manager name. And then here we have the frequency. Frequency. In this case, it's the number of accounts managed, right? And so we have data on, okay, so this account is William's account, this account is Smith's account, this account is Lopez's account, and so on and so forth. And then we come across this account is William's account again. And so then we get those frequencies, right? And so those are just counts, right? So these would be counts in a frequency table. And if you look at that supplement that I posted, the Excel how to do all these things in Excel, how to generate these graphs in Excel, you'll see that it's kind of clunky still. So Excel needs you to first make the frequency table, and then it can go from that frequency table to the graph. That's pretty old school stuff. And so R just does that built in, right? And so, but they're doing the same thing. They're counting how many are in each category and then summarizing with a graph. So typically, a couple of notes here. If you have text categories, right, then it's a lot nicer for readability to stack them like this. So to stack them horizontally, right? And so for text categories, we often stack them horizontally as above, right? For increased readability. For increased readability. Because it's hard. So now, right, imagine that this graph was tilted the other way. Then you have to read kind of William, Smith, Lopez like this, and it just is more work, right? And so even though the bars look nicer and we can read the bars easily that way, it's harder to read text. Whereas if your categories were 1, 2, 3, 4, 5, for example, that's fine. You can read it just as easily moving across, right? So it depends on what your categories are and what your category names are. Another thing that we would do to alter this graph, so this would be the default graph. Another thing that we would do is potentially have some sort of order to the manager names, or if we arrange it by the bar height, right? Because then it's going to be easier to see who has the most accounts, who has the fewest accounts, and who has the middle of the road accounts, that kind of thing, right? And so here, we could also, order the manager names. So maybe we're interested in just listing these managers alphabetically, right? That's going to be more in terms of something like an ordinal variable, right? Where you have order, natural ordering. Okay, so here we could argue that we could list these alphabetically, and so it could be an ordinal variable, or if it's more useful to us to know who has the most number of accounts to the least number of accounts, then we would organize them that way. So it just depends on what we want to know, what we want to emphasize. So we could also organize the bars to convey more information, right? For example, right, sorted by manager name, right? If that's important, right? If we want consistent comparisons across multiple quarters, for example, right? So if we want consistent comparisons by manager. Otherwise, if you're doing it, so if you're interested in how one manager performs over time, then you'd want to sort it by manager name, right? Because otherwise you're going to have to look for, okay, where was Williams here? Where was Smith here? And then where was Williams in the next one? So if they're always in the same spot, then that's one way that you could analyze it. Or you could sort by the number of accounts. Right? Usually from largest to smallest. Usually largest to smallest. Right? Something like this, where you have this bar and then this bar. A, B, C, D, E, for example. I guess they wouldn't be alphabetical, but you get the idea, right? And so then you can easily see who's the top account holder and who's the lowest account holder, etc. So it depends on the information that you want to emphasize. How we sort the bars depends on which information you want to emphasize. Emphasize?
Looks right to me.
Hey, sold. Ditch the question mark then. Be more assertive. Emphasize. Emphasize.
Oh, you're asking about punctuation?
No. I just didn't know how to spell emphasize all of a sudden.
Oh, I think you got it.
How about that? Emphasis on the emphasize. I'm always waiting for like a red line to show up. Doesn't show up when I'm writing by hand.
Yeah, you can get away with it when you're writing by hand, I think.
Yeah. Okay, good. So bar charts are going to be our go-to for categorical data, right? And so I do want to make a note about kind of these weird fancy charts. They're not fancy, they're just kind of bad typically. So we can make pie charts, right? And we can even make three-dimensional charts, especially in Excel. They've done all these like weird, cool looking graphs, like 3D bars, and just kind of, the readability is really low on those graphs, I think, and the rest of the stats community agrees. So phew, or maybe that's where I got it from, right? And so Excel put out, you can make a donut chart, which is really just a pie chart with a hole in the middle. Why, I have no idea, but they decided that that was something that we needed. And so, yeah, where's the Timbit? Well, that's a pie chart. Yeah. Donut chart, maybe it should be called a bagel chart. For some reason that didn't take off, but anyways, so there's some just some warnings here about don't overcomplicate things, okay? And so one key thing to remember about a pie chart is that a pie chart, it's really, really hard to see the differences between the sizes of the slices. So if we're looking at this graph here, let me bring it in. But first I'll say we should avoid using pie charts, donut charts. So stupid. Pie charts, donut charts, or 3D graphs. Because they are often difficult to read, right? And don't provide any more information. So are often difficult to read. And do not provide additional information. Okay. So I'll bring in this pie chart here. This is the same information that we had above, right? And so it's the manager and how many accounts were managed is the size of the slice. Hard to say. So here, without any values or anything, all we can say is that, well, it's not even really clear to me. I'd say it's a toss-up between this purple slice, Gentry, and potentially Lopez, for who, yeah, and if you're colorblind, you're gonna have a hard time here, right? And that's also something that we need to keep in mind. That it's hard to differentiate between these colors. So especially because we have so many colors. But I'm having a real hard time figuring out which slice is the largest, right? And so here, it is very difficult to see which slice is the largest, right? Whereas before, when we saw, and I guess if I'm gonna have to guess, my guess is the purple one, Gentry, but isn't it kind of silly that I have to go to the bar graph to confirm? That's weird, right? So here we go. It's A. No. Phew. But notice how, so this Gentry manager did have the most number of accounts, or the highest number of accounts. But even though it looks like in the bars, when I look at the bars here, right, it looks like there's actually quite a large difference between the number of accounts here. Whereas I was kind of going back and forth. Is it the green one? Is it the orange one? Is it the purple one? And so it's really hard to quickly gather information. And what's interesting is the textbook highlighted that our brains, I guess in studies, a lot of studies have been done here, our brains have a hard time looking at surface area and kind of converting it into something that we can measure, right? And so we have a hard time, just, I guess, as humans, visually, we have a hard time looking at this surface area. Whereas when we're looking at these bars, yeah, it's very subjective, right? Because I don't know, I'm struggle city here, right? Trying to pick the largest slice. The smallest one in this case is the easiest. Whereas here, when I'm looking at these bars, we can easily, our brain just kind of susses out which one is the largest one kind of naturally, right? And so that's something to keep in mind, right? Oh, there. So for this course and all your future courses, I hope you never use a pie chart or anything kind of weird or snazzy, no matter how tempting. Have I used a 3D bar chart? Of course I have. I had to check it out, but I ditched it because it didn't do anything, right? I guess it didn't do anything for me, right? But so just in general, for categorical data, yeah, a dream catcher chart. Yeah, it's all like boom, 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 boom. Oh yeah, all those layers. Oh yeah, if you're in the third, then that means something different than in the second ring. No, what a mess. Yeah, so anyways, so in this course, we will only use bar charts for single categorical variables. Now, as soon as we move into multiple variables, so if we've got a quantitative variable and a categorical variable, then we can do some other stuff, right? But for single categorical variables, we're only using bar charts. Okay? And ideally, you would stack them in some way where it's meaningful. Okay. So, have you guys seen any talks by Hans Rosling? He's a Swedish statistician. Unfortunately, he passed away kind of recently, but he did these amazing talks. And so if you want to see like kind of a really fun talk, you can look up check out Hans Rosling for really interesting statistics talks. I guess that's just a random plug, but the reason that I thought of it is because he would use bubble charts really effectively. In fact, I think they were interactive bubble charts. So he would like follow the bubbles around and look at all different kinds of data. So check out Hans Rosling for really interesting statistics talks. And he uses a lot of, or used, I guess, a lot of bubble charts. So a bubble chart, let's just see here, is one way that we can introduce 3 variables instead of just sticking to 2 variables like in a scatter plot, right? You've got your X and your Y. Then instead of introducing a Z axis, now we're talking 3D, right? 3 variables would require, each would require its own axis, right? That again, that's hard for our brains to look at and understand. So instead of doing that, what we do to, and we call it to flatten it, so to make it back to, bring it back to 2D, is if we want to look at 3 variables, then we can make a bubble chart. So I think I copied it. We'll see here. And for me, I would say Hans Rosling really kind of introduced the bubble chart, but I don't want to take it that far. I'm sure it's existed forever, but he kind of popularized the bubble chart. So now if we're visualizing 3 variables, okay. Yeah, so yeah, if you haven't seen a bubble chart before, it takes a little while, but what it looks like is it looks like this. Bring it in, if it'll let me copy. Someone should do a word cloud on my lectures. I think the words that I would say most, like the words, so you guys know what a word cloud is, right? Twitter analysis and stuff like that.
I am unfamiliar with such things.
Okay, so a word cloud is typically for text, obviously, because it's words. And so what it does is it takes kind of a string from Twitter or maybe our lecture. So if it takes this transcript, and then it just has all the words are written in the size that they were mentioned. So the words that I say the most would be the largest and kind of in the center. And then the words that I say kind of frequently would be of varying sizes around there to make a word cloud. And I feel like the word I say the most is probably, unfortunately, I try not to, but is copy. Because I'm always saying, if it'll let me copy this, let me copy that. And so in my word cloud, it would just say copy in huge letters. Copy, like, anyways, not a very
That's
good.
interesting. I might use that on myself someday and not show anyone the results.
I know, right? It's kind of like, oh, all right. Yeah, so yeah, there's my word. I know. My word cloud would be really bad. It should be things like analytics, quantitative. It wouldn't be. Bubble charts. Bubble trouble. So anyways, so here, right, we have, yeah, swear words. I try not to because, well, I shan't. So, but anyway, so here we're looking at 3 variables. In fact, these are quantitative variables. So I would probably extend it to just be for quantitative variables. There are some cases where maybe we could consider one categorical variable here on the x-axis, but for the size of the bubble, it should definitely be quantitative. And so let me just go back to this blurb and see if there was anything else I wanted to point out here. Yeah, I would probably insert quantitative variables. Quantitative. Or my word cloud would just be quantitative spelled out. Quantitative. Helping myself spell it. But so imagine, right, if you're trying to make a 3D graph, that's really hard, right? But now if we can kind of flatten it out back into 2 dimensions, that's good, right? And so what we have in the table is we've got a sample of 6 countries, and for each country, we have the number of billionaires per 10 million residents and per capita income and the total number of billionaires, okay? And so here it's got the description, but I just want to go through and kind of blab my way through it. So it's here if you need it, but because it can take some time to kind of wrap your head around it. But so what we have is we've mapped the billionaires per 10 million residents on the x-axis. And then we have the per capita income on the y-axis. We don't know what the research question was here, but having the per capita income on the y-axis tells me that that's my response variable, right? That's my dependent variable that I'm most interested in, right? And so here I'll say, since per capita income is on the y-axis, it must be the response or the dependent variable. So it doesn't really matter what the question was here. We're looking at billionaires. How do they compare both in kind of density, but also how many, right? And what's the third? Oh yeah, the number of billionaires. Okay. So if we didn't look at the size of the bubble for a little bit, right? Let's shrink these down and remove that variable so we can wrap our head around what's going on here, right? And so what it would say then is that if we have something like, let's look at Russia because it's nice, kind of visible here. Otherwise, we've got India, China, Mexico, Russia. So if we're focusing on Russia, then what we'll see is that we have roughly, I'll map it down here. I'm assuming that if we just had one dot, it would be in the center, of course. And if I map it down here, I can have a pretty good understanding of the billionaires per 10 million residents. It looks like it's around 7. So I can confirm using the table, right? Because I have Russia here. Turns out I was off a little bit by 6.2, but the scale, I don't have a very good scale to go off of, but that makes sense, right? And so 6.2, and then if I go over to the y-axis, which is the per capita income, well, I could look here and it looks like it's about 25,000, whereas here I can confirm it is 24,850, okay? So if I just ignore the number of billionaires for just a little bit here, right, then I would just have a regular scatter plot, right? Each with a point of one size at each of these XY coordinates, okay? So now when I introduce the number of billionaires as another variable here, that third variable, then I see that 88 is the number of billionaires, right? So the count of billionaires in each country. I guess that's sort of categorical, but let's just keep it quantitative for now. Number of billionaires. You could argue it either way, right? If you have data with each individual billionaire, then you could count the number of billionaires by each country. But anyways, doesn't matter. So then, if there are 88 billionaires compared to, well, even 213 or 103, 88 is quite small. It's quite a small number, right? And so the dot is quite small, right? Whereas if I look at 213, that's China. So 213 billionaires. So I'm expecting that China would have a larger bubble. So if I go and find China, sure enough, it has a larger bubble than Russia did, right? Even Germany I'm expecting, and now it's really hard for me to see. Again, we're trying to look at the surface area. So if I remove this here, if I'm trying to compare the surface area between Russia and Germany, if it's important, right, those actual values, then we should get them from the table rather than the graph, because I don't know about you guys, but I have a hard time seeing the difference in size between Russia and Germany, right? Or even Russia and India, right? It's easy to see that Mexico has the smallest, China is larger than the rest of this cluster here. United States is obviously the biggest, that no doubt about it, right? But if you wanted to look at the nitty gritty between India, Russia, and Germany, you'd have to refer to the table. So often it's useful to have both the table and the graph. Sometimes you're going to be kind of cramped for space. So then you wouldn't want to do that. Then you would just have your bubble chart, your visualization. And then often you throw the table in some sort of appendix at the back that no one reads. You spend a ton of time on it, no one reads it. That's okay. That's our job. So bubble charts are kind of fun. And we'll look at how to make a bubble chart in R. I don't know how to make one in Excel, and I don't remember putting it in that Excel document that I posted, but you could easily Google your way to it if you wanted to be using Excel instead. So there are a few things that are a little bit more sophisticated. We don't have the tools yet to look at, for example, a heat map in R. We will, but not quite yet. So we're going to focus on making a scatter plot, making a bar graph, making a bubble graph or a bubble chart, right? And then, but here are some other things that we could talk about. So a heat map. Heat maps use some sort of classifier. So if you're underperforming, you might be labeled in red. And if you're overperforming, you might be in the blue, for example. And so here, come on. So heat maps are pretty useful for quickly just summarizing a ton of data. Right, especially if you're always producing the same heat map, then whoever's reading it would be kind of familiar with the layout, and then it's easy to absorb that information because it's all color coded. So here, they've done this crazy summary where we have what they call same store sales data. I don't know what it is, it doesn't matter, it's sales data. And so we're talking about St. Louis, Phoenix, Albany, Austin. Isn't that like a song? Phoenix, Albany, Austin, Cincinnati, San Francisco, Seattle, Chicago, Atlanta. It could be a song. Right, and so it's got all the stores obviously here, and what we're looking at is for each month of the year, right? And so how did they perform for each month of the year? And so this is a really nice summary of a lot of information, right? That you would have to. It'd be very difficult to produce this same information so concisely in any other way. Right, and so then a heat map becomes quite useful. Notice that if you didn't have the coloring, then you'd have to go through and you'd have to read every single number. So the coloring kind of eliminates that. And so going from dark blue to dark red, dark blue being high percentages, high positive percentages, moving to the dark reds, which seem to be low negative percentages because they're negative. high negative percentages. No, let's stick to proper low negative percentages, right? And so, and then white is kind of some area, right? So it seems like 2%, 2%, 3%, 4% are all kind of relatively lightly shaded. So they're all kind of okay. There's nothing to be concerned about, right? And then if you see a line where it's dark blue all the way across, then we get excited about that probably, right? Because that's probably what we want, right? We want all of these to be blue ideally, but they're not, right? So then, although it's fun to see all these kind of straight across blue ones so often here, usually we're not concerned with those. We applaud those and say, hey, good job, guys. But it's more if we see something like Pittsburgh, who's consistently red all year here, different shades of red, right? You could look at who has the most red, who has the most shades of red here. And sometimes it'll be helpful to include the sparklines here, right? Just to see if there's some sort of trend. Notice that there's no axes. So it's all just kind of relative, right? And so, but here, right, St. Louis started out in the red and then they worked their way up into blues, right? Whereas here, Phoenix started up in the blues and then went kind of deep red and then went up a little bit and then down a little bit. And so we see that with these sparklines. And so the sparklines summarize even more information, right? They summarize kind of the trends of the colors across here so that we can compare them. For me, the axes are missing, so it's hard to interpret, but I guess someone who looks at these for a living and makes millions of dollars, yeah, they probably like these sparklines just to see what's going on, see more. Okay. But I can't think of a better way to summarize all this information, right? Every single month for every single store that you have just on one page, right? Okay. Oh yeah, this is just talking about that heat map, so that's okay. One thing that I do want to point out is the different colors that you use. So you have to be really, really careful when you're choosing colors. We talked about color blindness before, right? And it's it can be a real problem, especially if you have tons of different categories, for example, that you want to talk about. You're going to start to run out of colors, but you want to make sure that each color is distinct from another color. And there are websites that can help you pick out kind of contrasting colors. So they've got this color wheel, so you can pick your main color and then it'll pick kind of all your secondary colors for you. Can't remember what that site is called, and I'm sure there's lots, right? But you could kind of Google color picker or something like that, and it'll come up with lots of different options. But yeah, so heat maps depend strongly on the use of color, right? And so you want to make sure that the colors are easily differentiated, but also that they do not become too overwhelming. All right. So just something to keep in mind. Yeah. And I would have loved to see maybe a legend here. Oops, hey, I guess it worked. Didn't mean to highlight that, but I would have loved to see wait, relevant to the semicolon. Anyways, missed it. I would have loved to see maybe a legend of the colors, but that's just me being picky. Oh yeah, relevant to the temperature. Yeah. Okay. Hey, what time is it? How long was I out? I'm gonna be short on time again. I'm always running out of time. Okay, so if we want to talk about, so we decided that we're going to use bar charts for categorical data, right? But then there might be times where we have maybe two categories that we want to consider, right? And so then we can use something like this, and maybe I'll do this. Come on. I guess if I get distracted, it's my own fault. But I'm easily distracted. So if we have multiple variables, right? And so now we're talking about multiple categorical variables, such as maybe we have the months, right? And then we want to look at the south versus the north. Yeah. There are a couple of different ways that we can do that. So the first way is a stacked bar chart where each bar is, you know, given some amount of space for each of the categories within it, right? Another way that we could do that is just to split them up. And often I like to split them up like this, but it can make a real mess, especially if you have, you know, if you have the same number of bars, but now let's say you have 6 different categories here, that means that each month would have a cluster of 6 bars, and that becomes a lot, right? So in that case, I would probably opt for something like this, where I could look at the different layers, the 6 different layers in that case for each bar, and compare them that way. And then of course you could split them up, but often that's not very useful unless you're focusing your analyses on one thing. Okay. So here I do want to make a note. Notice the consistent color scheme. That's going to be really important. So if the south is red and the north is blue, you don't want to be changing that halfway through your analyses, right? So you're going to set up your legend essentially at the beginning of your analyses and stick with those colors throughout, right? And so you want to pick colors that are complementary, but also distinct, right? And so notice the consistent color scheme. The color scheme for north, which is blue, and south, which is red. Okay. And so our analyses should always be consistently using the colors that you set out in the beginning, right? And so you don't want to be mixing things up. Okay. Another thing we could do is we could look at something like this scatter chart matrix. So a scatter chart matrix, here we're looking at the median rent, the college graduates, the poverty rate, and the commute time. So these are just variables, who cares what they're from, against median rent, college graduates. Hey, it echoes in here, poverty rate and commute time. So I've mapped them against themselves, right? But that gives us a series of scatter plots, right? Notice that across the diagonal here, you've got this perfect y equals x situation, right? Because the median rent mapped against the median rent is going to be just a straight diagonal line. right? And so these ones on the diagonal are not interesting because they don't tell me anything, right? But by doing this, I can look and see how the median rent relates to the college graduates, how the median rent it has a relationship or relates to the poverty rate, the commute time. And this is going to let me quickly pick up the strongest relationships, maybe the most interesting relationships, right? And so here, variables mapped against themselves are found on the diagonal in fact, they give a diagonal line themselves, but I'll ignore that for now. And are of no interest. Right, I only say that because I don't want you to start talking about how the college graduates relates to the college graduates. You wouldn't, but just in case, right? And so, but I can use this scatter chart matrix. We can use this matrix or scatter chart matrix to quickly understand many relationships, right? Notice that we only need one of these triangles, right? Because if you look at the college graduates versus the median rent, and then you look at the college graduates versus the median rent, it's been kind of flipped, but it depends on which one you want on the y-axis and which one you want on the x-axis, but then they're going to be the same, right? And so we only need to look at one of these triangles. In fact, I'm going to zoom out, right? And so here, we only need to look at one of these. So we can use the scatter chart matrix to quickly see relationships between variables notice we only need to consider, I'll do this, to consider one of the triangles. Since they are the same, or since they are graphing the same information. They're not the same because they're kind of, they've been transformed a little bit, X and Y axis, but since they are providing, that's what I'll say, providing the same information. So I only included, well, definitely these advanced data visualizations, just so you can see them, and not really much to say here, but I will talk about these maybe at the beginning of the class next day, but not for a long time, just to see what's going on. But then I also just briefly want to talk about data dashboards. But then what I want to do is, I said on our Moodle page that we would do it today, but I want to go through and work through some of those in the R for Data Science textbook. let me take you to our Moodle page. So here, I was kind of scrambling for where I would be today. Turns out I'm way slower than I thought. Chapter 3, we'll finish chapter 3 and ggplot. So what I wanted to do was do the explore data visualization from R for data science. So what I encourage you to do is work through it on your own. ggplot can be kind of a beast to master, but we're going to start nice and slow. And then what I've done is I just Googled it, but I also posted the R for data science exercise solutions. So they're not something that you're going to be handing in, but I do encourage you to work through those exercises, just to have an idea of, what you can be doing. Okay. And so the R for data science textbook, and then on the left-hand side, you can see explore. And so on Wednesday, I guess, I want to work through this data visualization section with you guys. Okay. Not all of it because it's really long, some key aspects, right? But you can play around it beforehand. And I'm double out of time. So if you have any questions, let me know. Otherwise, I'll see you Wednesday and I'll stop this.